Very good evening and very good morning to everyone. Today I'm discussing about there is a new concept called as a neural networks. So which is little different from the earlier techniques. Yeah. So let us understand what steps are going to be involved into the neural networks. So very carefully you listen the class. So these techniques are not so formally or maybe systematically goes. Completely they will be iteration level or maybe many more new parameters you are going to learn about it. So neural networks is exactly works as a simulation of a human being, correct? So yeah, so if you look at this picture, you will be seeing there are two pics basically, right? So neural networks is a machine learning models only, but the way they follows the way they learn the things will be little different. But we can say neural networks are machine learning models that simulates the complex functions as like a human brain. So as a whole, neural networks can be a simulation of the human brain. The way how we are going to learn human, how we are going to reason out, how we can able to reproduce, how we can learn from the experience. In a similar way, mathematically, there is an approach is designed such a way that the neural networks algorithm will be look like a human related behavior. Okay, and absolutely, if you look at so these models are they will be interconnected, like so here these models like algorithms, they interconnected with the nodes or neurons to process the data and learn such hidden patterns and enable the tasks such as pattern recognition, decision making. So here I would like to tell you one thing. Let's suppose you have seen linear regression, you have seen logistic regression. So linear regression is to predict the target value to forecast the continuous data. But whereas a logistic regression will understand the continuous data and it will be categorized like a binary classification or multilinear classification or ordinal classification. Okay. So in the same way, if you look at this particular picture, in this picture, you see this picture is, it's a simulation of a human neurons. So in this, basically, this particular dot indicates, circle indicates. So a nucleus, which means it look like the neurons actually, So whatever the nerves will be connected to this particular neurons are going to be treated as dendroids. And if you wanted to process some info from one particular place to another particular place, from one particular nerve to another particular nerves, so the communication will be taking place in the form of axon, and this particular thing will be call it as a cell body, and the output will be processed to the other place according to the desired thing. Let's suppose I wanted to shake my hands, which means you are giving an input instruction to your neurons such a way that the communication will be taking place through axon, and the hands are going to be give you the movement. The giving movement by the hands are going to be outputs, but the actions will be started from here. So these are all, completely, it's like a one machine. The even human brain and human neurons are going to work like a brain, but we are not able to see that. But doctors can able to show you how exactly the communication will take, how inputs will be given to your brain, so that wherever you are expecting an actions to be produced, how it will be goes through the neurons, through the dendroids. It will be show you absolutely pictorially by the doctors. Like, human naturally we don't understand how the things would happen. But as a whole, uh, this is the neurological human related process where the steps are going to be involved. But this is the equivalent mathematical simulation related model. Yeah. Yeah. So now, if you look at it very in short form, this is look like neural network architecture. Neural network architecture. So where there are some neurons or nodes. I already said they will be call it as a nodes or can be call it as a neurons. Like no, here this can be a one neuron, this can be a one neuron, this can be one neuron, or this can be one neuron. They can also be called as a nodes. Okay. If we give inputs to the next layer, that's going to be, this is going to be the hidden layer. Hidden layer. Hidden layer. Here there will be an output layer. It is going to be the hidden layer. This is going to be the input layer. Right? So here we are going to pass the inputs to the hidden layer such a way that the hidden layer is going to add some weights W1, W2, Wn or indicates weight, and B indicate bias. This particular portion indicates the process is done by the hidden layer where it will be taking an inputs from the neurons or nodes, and it will be add some weights and bias using a linear function, using an activation functions, and the desired output is going to be produced as an output by the output layer. It is very simple form, but some mathematical terms and mathematical computations are going to be involved in it. Let us see little ahead. Little ahead, because by seeing the diagram, by seeing an architecture abstract diagram, you don't understand how the things would happen. We'll take some example and will be process how exactly this abstract diagram will does the producing the outputs. Okay. If you look at this next slide, yeah, the neural networks has a lot of different algorithms. They are classified as feed forward networks. Feed forward networks means the input will be go and computation will be taking place in the forward direction. Input to hidden layer to the output layer. That's one kind of a network. There certain algorithms have been designed. Okay. There is some drawbacks with the feed forward networks. Hence, we do have another kind of a flavor or another kind of an advanced little other algorithm is called as CNN. C indicates convolutional networks, convolution neural networks, I can able to say. And another kind of algorithm is very popular algorithm. These two are going to work with something called as regression kind of a data, continuous kind of a data, classification kind of a data, but whereas categorical data, but whereas RNN indicates recurrent neural networks. This algorithm is made where the data is a time series data or sequential data to be handled. Especially they may time series data or maybe a sequential data where based on the time within an interval of a time wherever the data will be continuously generated to handle what like a stock market price. Number of transactions can be done per a day. Tomorrow will be increase or decreasing. These are all kind of data will be call it as time series data, or we can call it as a sequential data. Such kind of a data are going to be predicted using especially made RNN. especially there is an algorithm is called as LSTM. LSTM is nothing but long short term memory. There is an algorithm down the line I'll be discuss about. Okay, and comes to GAN. Now you might have heard about GAN, generative adversarial networks, and autoencoders and transformer networks. These two are very important, especially now we are having a generative AI and as well as agentic AI, whatever the frameworks we have, they likely to use these particular algorithms are more and more clear. So these are the types of the neural networks you have to understand about these, because when the different terms you are going to listen in the textbooks or somewhere else, don't be get conflicted, because you should have a correct idea that what is the forward feed forward networks and what sort of algorithms comes in, and what it is a convolution neural networks, what kind of an algorithms comes in, and what are the back propagation, neural networks, and forward propagation, BPNN, CPNN, ANN algorithms, and there are algorithms actually. So whenever you see the list of algorithms, you will be get conflicted. So if you have a correct classification of an algorithms idea, you will be not going to get any kind of a ambiguity. Correct? Yes. Next, yeah, if you look at this particular slide, I have explained in the second slide, right, about there is a architecture. Here, if you look at this particular diagram, here I have shown you these are input neurons or nodes, where you are giving, there is an input feature 1, feature 2, feature 3. Means feature 1, feature 2, feature 3 means in the table of data, if you have a x1, which means feature 1, probably temperature, x2, humidity, x3 is outlook, such a way that what could be the whether can we play the game or not is the why. What is the target? If you have a temperature, humidity, and as well as the outlook, there are samples in the data set. Based on these particular inputs, our aim is to be predict can we play the game or not because of these particular symptoms. So the game is going to be predicted as a y1 as a y2, which means y1 and y2 will be what? Absolutely, it will be predict that if the rain is likely to come, then obviously it will be, of course, otherwise if we categorized as a 1, which means the temperature, humidity and outlook will be favorable to play the game. If it is a 0, then it is not favorable to play the game. But what about this particular inner? These two are the, these two are the hidden layers. The hidden layers, number of hidden layers might be increases also. Maybe only one hidden layer would be there, maybe two hidden layers would be there, maybe three hidden layers, maybe depends on the complexity to solve the problems. We can have more than one hidden layer. What exactly the hidden layers are doing here? What exactly the hidden layer is doing? So I already told you that in the previous slide, that the hidden layer will have a sigmoid functions are calculated, tan h functions are going to be calculated, and absolutely the errors are going to be calculated, weights will be added. All these are the mathematically we are going to do it as a whole. In any neural networks techniques, you will have an input layers in certain few neurons you will have, hidden layers having few neurons will have, and output layer will have a few neurons over here. Output layer can have a one particular neuron. It can be a two. It can be more than two also. For what purpose we are designing this particular architecture, there should be a proper problem to be solved. Is a problem is, is that data is having a continuous data, regression data, categorical data, what sort of output you are expecting. If you look at here an input layer, this network, this input, where exactly they receives input data like a temperature or else, age, height, then weight is going to be predicted. It is a regression kind of a data, right? So each input neuron is the layer where corresponding the feature in the given input data from your data set. From the data set. So once the data will be received at input neurons, then the second layer, hidden layer, is one or more multiple hidden layers would be there. This is combinedly called as a hidden layer. This is combinedly called as a hidden layer, but it can have each layer consisting of neurons that transform an inputs into something that the output layer can use it. Whatever the process you will doing in this hidden layer, see, hidden layer is exactly like a CPU, central processing unit. It performs certain operation and it understands the patterns or trends or correlations in the data set which you have provided the inputs. Based on that, the output will be produced. Yeah. And the output layer, absolutely, output layer is, it produces the output uh, and it will be produces output based on the specific target you are expecting. So the problem is a classification related problem or regression related problem. See, even images can also be classified. Even the videos can be classified. Even input numerical data can be classified. There are many more algorithms we have. There are many more problems we have. So neural networks is very powerful. It is also known as a deep learning. So I think please, your attention is very important here. Yeah, yeah, yeah. So if you look at now a little important components of the neural network is that first one is a neuron. I already told you that neuron is also known as a node. That's a responsibility that receive an input. Each neuron is associated by a certain threshold and an activation function. What is a threshold value, what is an activation function, and what is a weight, what is a loss, all these things, with mathematically we'll be able to we'll be able to understand now. And connections, obviously, between input layer to the hidden layer neurons and hidden layer neurons to the output layer neurons, there will be the links have been established. They carry the data or information in association with the weights and biases. How the weights are going to be allocated, how bias are going to be assumed, all these things will be seen mathematically. So absolutely, weights and biases are very important factors in the neural networks used by the hidden layers. These parameters are determine strength and influence of the connections. Probably theoretically, we won't be able to give a justification. What do you mean by weight and what do you mean by bias? See, let's suppose I'll tell you a small example. If you wanted to enable the bulb, if 24 watts are going to come to your home, the bulb is going to exactly produce the right resolution. If there is a low voltage would come to your home, which means we have to adjust the voltage. That adjusting the voltage is nothing but these weights and biases we can also, because If only the current has only positive and negative, there is no ground, that is called as a negativity, then the I think current will give you, electricity bulb will give you shock to you. Sometimes whenever you touch some kind of a parts of your house, it will be give you a little shock because there is a reason is that there is no ground connected to your bulb, to the voltage. That's how to produce something output. There are certain things are hidden that's not going to be visible to you. But now it's time to understand what do you mean by weights and biases. That's what weights and biases are, the parameter. They will be strengthened to the a process, and in order to perform the smooth output according to our expectations. Propagation functions are mechanisms, or maybe they will be the concepts. Forward propagation, backward propagation. So they will be help the process to transfer the data across the layers of your neurons. So what would happen? What is the forward propagation? What is the backward propagation? I think you will get to know with appropriate algorithms. Comes to the learning rule. For every algorithm, we will be able to give there is a learning rate. It adjusts the weights and biases over a time to improve the accuracy. So if you give 80% of the learning rate training data to the algorithm, it could be, one particular accuracy. What could be the learning rate? It can be a 0.1, 0.2. Like there will be certain threshold values for the learning rule also. So how it will be helpful? While seeing the algorithm parameters, you will be able to understand about it. Yeah, rest of these slides are related to RNN and long short-term memory, how RNN are understand the sequential data or maybe a time series data, and how the models are look like. All these will be on examples and everything. I'll be tell you after a few days, because it's time to think about a forward neural networks, which is a FNN. Yeah, let us go with some kind of a mathematical approach. Some kind of a mathematical approach now. Yeah, so where let me okay, I'll be create here. There is one folder. Yeah. So in this folder, I'll be whatever the uh, yeah. I'm just keep yeah. Okay. So now yes. Yeah. Firstly, let me execute one program to you to classify the data. The name of the algorithm is FNN for classification. For classification. Yeah. So now I'm demonstrating to you how the neural networks is going to work with a sample example for classification. So we are discussing about as a problem is a feed forward neural networks for classification problem. For classification problem, isn't it? So in order to do it, so we required certain libraries. They are different from the earlier. Obviously, we required NumPy as NP and import pandas as PD, and from there will be TensorFlow is the name of the. Let me connect. Let me connect. There will be TensorFlow is the name of the a library, which is a library in which there will be Keras. I hope you are seeing tensor. Yeah, I hope you are seeing TensorFlow dot Keras and import within the Keras there will be the models dot models import sequential. You see now there will be a model is called as a sequential. Okay, this is the one particular library in order to work with absolutely with neural networks. And apart from this, to create certain layers from the TensorFlow, dot Keras dot layers. Import dense. Yeah, dense is the name of the method with which we can create a layers. Okay. Yeah. I hope till here everybody understand here. I think you can able to practice in respective with me. Okay. So now we have to create a sample data set. Create sample data set. The data is going to be, I'm creating it now, where, as I said, input layers require the features, right? Now you can able to create a, like, feature one. Feature one is the one particular input where you are giving certain values. Probably you wanted to um, uh, classify based on the sugar, a diabetic level, and based on the BP level, whether you have diabetic or not. I wanted to take. Feature one is what is the sugar levels you are going to be recording here. 0.1, 0.2, 0.3, like 0.4 and 0.5. Like that, we can able to take some samples. So what is the feature one? Diabetic level. Like, your, let's suppose your sugar levels, I could able to see. Okay. The next is that feature two. Feature two, where it is look like a dictionary. You will be able to record something called as a 0.5, 0.4, 0.3, 0.2, 0.1. This is how you will be able to take. And apart from this, absolutely there is a target variable. Whether the target variable is based on the symptoms, diabetic level and BP level, whether you are belonging to have a sugar is there or not. There are two categories, 0 or 1. If 1, diabetic is there. 0, there is no diabetic. So where exactly I'm trying to create, there is a label. There is a label where absolutely I can able to create for 5 records 0, 0, 1, 1, 1, which means what? Here, obviously, if you divide this particular thing as a data frame, now you convert the data, you'll be get to know. This is the NumPy array, right? Like now you can able to convert into data frame. Def is equal to pd dot, data frame, where data. Then you just trying to display the data. I think how it is look like. Let's look at data set. Now I hope you understand. This is the table. It's like a data set. Absolutely. Yeah. This is input 1, which is going to be the x1. This is x2. This is the label, which is y. Absolutely any supervised learning techniques are going to be work y is equal to f of x. The data should be in the form of this, then only we can able to predict the, we can train the model, we can test the model. So why we know that label? It's a categorical, binomial. Inputs are x1 and x2. Yes or no? Now these data set, how we are going to be, now we have a complete data set. Now it's time to divide what are the input features, what is an output feature, we have to divide it now because we haven't done so far. Okay. Now the next step is that, isn't it? Define a input features and output or target variable. Target variable. Now absolutely x is equal to data frame, whatever the data frame you have, there actually the feature 1, comma feature 2, feature 2 are going to be the input variables. Now comes to y, absolutely you have data frame where you will have a label. Yes, that's all. So these two are going to be the absolutely values are important here to divide them. So once if we execute, some error has been thrown. What is that? Feature 1 feature exception was direct cause of following exception.
Sir, we should keep double square braces for x.
Yes, absolutely. Thank you. For X only, especially. Yeah. So whenever we have more than one particular feature, you wanted to make it as an input, we supposed to give like this. That doesn't throw any kind of an error. Thank you, Rajalakshmi. Yeah. Yeah. So here you can able to see what kind of an inputs we have. Yeah. So now obviously you have a only feature 1 x1 and feature 2 x2 will be divided. Now the y value is isolated from the data set because we have clearly required input features and output features in order to supervise or in order to train the data. But now we are training the neural networks model. How it will be happen? Let me tell you. Now similarly, y can also have a only corresponding data. You see. Next. The next is that now create a neural network model now. Now create neural network using method called sequential. Yeah. What I'm doing here now, absolutely, I'm just trying to instantaneously, I'll be instantiate. There is a model is called as a sequential. Okay. With this line, the neural network model is created. But we have to specify, right? How to create a model, how many input, how many input, how many input neurons will be there, and how many hidden layers are there, output layers are there, how many neurons are there. We supposed to specify, we have to instruct it so that it will be able to create it now. So model dot, there will be a method is called as an add. There is a as an add for which I'm going to create dense. There is a method is dense. I told you dense is the method in order to create the layers where I'm trying to create a I'm trying to create 8 hidden layers. 8 hidden layers. And input dimensions are input underscore dim. Input underscore dim is equal to 2. So input dimensions are going to be the 2 because feature and we feature 2. But the hidden layer is going to have a 8 what is called neurons. Next, there is an activation. I told you that there is an activation function would be created. This is going to be the ReLU, which is going to be the ReLU. ReLU is nothing but there is a mathematical perspective how the ReLU will work. LU is nothing but linear unit, where the ReLU is responsibility to handle the nonlinear data. So in order to do that, absolutely the ReLU is the function which is required. Okay. So now with this, with this created a input layer with two neurons and a hidden layer with 8 neurons. Yeah, that's all. The next is that we wanted to create an output layer. Output layer. Okay. So where I'll be create a model dot add dense. There is a method is called as a dense, where exactly I'll be specify one as the layer, where exactly I require only one particular output neuron to produce either diabetic you have, one will be the output. If you have a zero, then obviously another one is there. Yes or no? Like, here I would be able to specify an activation function, like activation function, where exactly called as a sigmoid function. This sigmoid function already we have seen in the logistic regression, which is going to be the S is equal to 1 divided by 1 plus e to the power of minus x is the sigmoid function. Already you have seen the sigmoid function. The sigmoid function is going to be useful in order to produce the uh, probability that the output is belonging to the category 1 or 0, because we have to after processing the data, we have to make sure that the data is whatever the sample you are trying to test is belonging to the probability is that 1 or 0. We have to make sure, right, that the sigmoid function is going to be make sure about it. Yeah, with this we have created a model. Now.
Sir,
Yes, that's all.
why did this 8 we have taken for the dense?
Hidden layer, like the output now, the
Mhm.
model is architecture is going to be like this.
Okay, so how do we know that it's okay?
Yeah, let us know. We will be calculate mathematically.
Okay.
So, that's what. Firstly, let me execute this, then let me come like this. I have written all the mathematical
Mhm.
things also.
Okay,
Here,
okay.
I have added 8, right? You
Yeah,
have given the input as, what is that input you
two
can take now?
features.
Ah,
Mm.
Age and salary. Means
Yeah,
feature 1, feature 2 we have taken, right?
feature two. Yeah.
See here, everything cannot be visualized, Rajalakshmi, but we
Yeah.
can see the output as per the desired output. Here,
Mm-hmm.
the neurons, like 8 neurons hidden layer, like
Yeah.
connections are look like this. You see like this.
Okay, okay.
Connections are look like this.
Mm.
Similarly, like this also. It's like a mesh. It's like a connections between all the
Connection.
hidden layers are connected with the input layers.
So if we take
That's what
multiple
we need
inputs
to
like
eight neurons. Hmm.
5 or 6 inputs in that case?
Yeah, why not? Definitely. No, we have taken only age and salary.
Agent salary.
That's what
Yeah.
you have taken only 2 neurons. Sometimes if number of features are more, probably age, the salary, and your outstanding
Department.
skills,
Yeah.
department, probably your experience, number of years of experience. If you take more number of
Mm.
input features, input layer have more number of neurons, right? See here,
Hidden layers. Yeah.
our brain simulation we are doing mathematically. It does not mean you are not understanding anymore here. Everything will be get to know. Nothing is impractical. Everything is practically calculated here.
Yeah.
Now here, according to our input now, only one layer is there.
Yeah.
That's all.
Yes, sir. Got it.
So now you please understand, in while creating the model, what this is the input layer, this is the hidden layer, this is the output layer.
Output layer.
Now in this, I have specified there are two important functions. One is activation function is ReLU. Another one
Okay.
is sigmoid.
Yeah.
What they do, what they do is important here. So what is the weight matrix? So that we can able to see here. So that's what, don't be too rush. Just let me finish that practical problem so that we'll come back to mathematical, because here I told you that, right? ReLU
Yeah.
indicates rectified linear unit. It eliminates the negative values from the input data set. While calculating the activist function, you will be getting certain like negative values also. The formula to calculate the ReLU is that f of x, function of x, is equal to max of 0 comma x. So it will be whatever the x values, input values you are passing, that will be multiplied with a 0. If any negative values are there, it will be make it as 0. You see here, our output will be like this. So the ReLU is going to vanishing the gradient problems, which means what you see the here you see input. Let me 1 second. Just sigmoid function will be using this 1 divided by, and okay. Just hold. Uh, hmm. Yeah, again I'm taking sample example 2 comma 3 x1, and yeah. So if you look at here, so we are calculating the weight. So the weight is going to be calculated for every neuron, for every input. Z1 I'm going to be calculated. It produces the 8 different Z values for 8 input values. 2 into 8 means 16, we can say. Yes or no? So if we calculate X value as 1, uh, multiplied with a W1 and added with a bias, so that the values are going to be generated like this. And the ReLU will be like this. Z1 will become as an input, so that what happens here, let's suppose Z1 values are like this. The ReLU is going to produce output like this. This value have been eliminated and made it as a 0. Let's suppose what happens, this is 0 and -1 have a made as a 0 and minus 0.2 will be made as a 0. So a data set should not have any kind of negative values while processing the activation function. So the output of the ReLU, which is the rectified linear unit, is like this. It eliminates the negative values from the input data set after calculation of the weight. Then output layer is going to be take like this. For every input layer, we are going to be calculate. Hidden layer is going to calculate it like this. Sigmoid function will be doing calculated like this. See, that's what, after that, the sigma function is going to have a 1.8, which is going to be the, if we calculate this, the output is going to probability is 0.858. Obviously 0.8 will be greater than 0.5, right? This is a threshold value. So
Yeah.
greater than 0.5 will be a class 1, less than 0.5 will be the class 0. This is how the output will be given to you. So now let me go back to here. Let's come back to our programmatic approach. Then I'll be come back to the that whatever the mathematically I just derived. So after creation of the network, we have to calculate the loss function, right? Absolutely, we have to calculate the binary cross entropy and accuracy RMSE and optimizer we have to specify. So next is that uh, compile the sequential model, compile the sequential model by specifying by specifying loss function, loss, comma, and optimizer, comma, accuracy, which is absolutely, we are taking the regression related problem, right? Inputs are regression. Obviously, we can able to check RMSE, root mean squared error. Okay. Now what I'm doing here, so model dot, there will be a method is called as a compile, where I would be specify the loss function. The loss function is going to be the binary cross entropy. Binary cross entropy. This is the name of the function, which will be calculates the what is the bias, so that either forward propagation is enough or back propagation is required. Based on the loss, we are going to be trying 100 times of the epochs, so that the loss is getting, so the any model should have a minimized loss will be the expected. Okay. Then the optimizer, which is going to be, there is a one optimizer called as a ADAM, which is indicates adaptive moment. The name of the function is adaptive moment, ADAM. Okay. Then there will be metric. There will be metrics, which is going to be the accuracy. That's all. So, so where here we supposed to be specified the accuracy within the square brackets. Yeah, that's all. So with this, the model will be provided during the hidden state, during the hidden layer. This particular functions is also be computed. Okay. Then the next thing is that we have to train the model now. So we have created the model with appropriate parameters for the hidden function to be computed. Now the time to train the model, we have to train the feed forward network sequential model. Now, absolutely, we have to create the model dot fit, where I'm going to specify X. Capital X indicates what input features we have, feature 1, feature 2. Y will be the target variable. And here I'm going to specify epoch. Epochs are nothing but each data set, like entire the data set will be scanned, will be iterate 100 times. It will be trained 100 times. And the batch is going to 1. Batch size is going to be the 1. And absolutely verbose is equal to 1. Verbose is equal to 1. Please you observe carefully what is happening here. What I said, whatever the input data set I given, whatever the Y or target variable I have given, will be above model will be trained 100 times. You see the output now, what is happening here carefully. You see the model is computing the weights, accuracies, optimizers and loss functions and sigmoid functions and as well as ReLU 100 times for the above data set. You see, loss is calculating, you see, 100 times. 100 times epochs have been calculated. Then absolutely now the prediction would happen now. Once the model is trained with a given data set, it's time to test the model now. We predict the model. Now I'll be take a test data is equal to numpy dot array where I'm giving a test data, which means what? I'll be giving you that 0.2 is the diabetic level and 0.4 will be the BP level. I wanted to classify because our model is already trained with sufficient data, right? Now our model has to be classified this symptom will be categorized as the having a diabetic or not need to be done. So now prediction is equal to model dot predict where I'll be give the test data, test underscore data. Okay, then obviously I already told you that the predicted label, I'm going to be keep it as a predicted label. I'm going to be the prediction will be greater than 0.5. This is the threshold value. This is the threshold value as type integer. The probability of the above data set will be probability lesser than 0.5. It will be categorized as the diabetic don't have. Greater than 0.5 will be categorized, you know what? Absolutely, you have a diabetic. So, right. So now let me execute. Absolutely, you see the output now. Print predicted label, comma, absolutely predicted label. You see the output now? It will give you as 1, which means this symptom is predicted by the feed forward network as 1. You can change the value otherwise. You can change the value rather than 0.2. You can take 0.8, 0.4 in place of the 0.6. Now we execute and you can see that now. This also comes under this, or else 0.1, 0.2. You see this and see this. This is also belonging to the same, isn't it? So this is how the values are going to be categorized. Labels are going to be categorized based on the given symptoms. That's all we want, right? We want this is output we want, that's all. So whatever the given input, whether it is able to predict perfectly or not is a point now, isn't it? So this entire thing is going to be you please I think time is now, I think about 10. So I think this file is available for you. You please test it properly. In tomorrow's class, you know what ReLU will do, what sigmoid function will do, how this particular activation functions will be go as a matrix way. I'll be explained to you mathematically. This process is completely doing programmatically, but how internally this loss is going to be calculated, what this accuracy is doing, and what this ReLU is doing, what sigmoid function is doing, how this particular denses are creating, I'll be explaining you theoretically whatever the things I have specified here. Right. So I think that's all for today's class. Mathematically, tomorrow whatever the program I have written, with respect to that, we'll calculate it. Is that clear? Yeah. Any
Sir, I have
questions
a
from
quick
your end?
question.
Yes, ma'am.
Yeah. So, sir, predicted label 1. So that means it's binary 0, 1, yes or no, or what is that 1? Predicted label.
Yeah, obviously, right. It's basically, you know, binary level. We have specified that only, right?
Yes or no?
Labels like 0 or
Yeah.
1.
0
Correct,
or
correct.
1. Okay. Yeah.
Yes. See, as a result, you know, any machine learning techniques or deep learning techniques, if the data set having complete numerical values, that's the reason min-max scalar we are using, right?
Yes, sir.
Correct. So maximum we trying to be avoid the labels or maybe input features or output features shouldn't have a categorical data.
Yeah.
So which means that, you know, the mathematical models always understand a quantitative data, not qualitative data, right?
Yeah.
Generally, whenever we talk about some kind of input values, the temperature is high, temperature is low, temperature is medium, like that we'll talk. But all medium, low, all these will be using scalar, min-max scalar. We are converting them into
Yeah.
0, 1, 2 like that, right? Yes.
Yes, sir.
So
Yes,
that's
sir.
what
I got
my
it.
justification is.
Yes, sir. Yeah, got
If
it.
you
Got
go
it.
with a multinomial, you go with a 0, 1, 2. You take to like, you change this particular data set now,
Mm.
Rajalakshmi,
Yeah.
rather than feature 1, feature 2, feature, you take one more feature. BP, sugar, pneumonia, you take 3 features you take. Then the labels are maybe 1, 2. If you go with something called as another example, like, multinomial means student grades, yes or no? A, B, C, probably 0,
Yes,
1,
sir.
2. 3 labels we are going to get. So please, you can imagine many more
Yes.
examples and increase the number of input features and increase the number of labels also. Please, you try with a 3. Yeah, please, tomorrow, and please, you just, I'm keeping this particular file in your drive. Please, I request Rajalakshmi, you going through, and I required, and few steps I have solved here in this. Few activation functions and ReLU value and sigmoid functions I calculated. So please, you apply for entire the thing, you just write the mathematical thing step by step. Please, I'm just giving you the task to you. Please, if you have time, please can you do that? Because I calculated up to some extent the values. So here I just calculated the values with the 2 inputs, x is equal to 2, 3, and then I calculated what is the weight value will be calculated, how it will be produce the values, and what ReLU will do. Only for one particular sample I have done. So can you do it for the all the steps, whatever it involves? What is the output layer will be given? So what sigmoid function will give you all this?
Yes,
I
sir.
need an expansion of all the values. Step by step, you solve it. Take only
Yes, sir.
two input features and calculate for every step hidden layer what exactly it is doing, how the weights and things ReLU will calculate. So just expand this. I'll be give you this particular file to you. Yeah, yeah. That's a great helpful for me if we expand it. Yes. And this file is anyhow available for you in your folder. See, I think here it is available. Feed forward network for classification. Okay. Please, I hope everyone is understand. Do you have any questions?